Welcome back. In our last session, we mastered basic loops in C# using for, while, and do while to repeat code. Today, in session 2 of week 4, we'll learn how to take control of those loops with break and continue, explore nested loop patterns, and work on practical challenges. Over the next few minutes, we'll explore break, continue, and nested loops, plus guided practice and lab work to cement your learning. By the end, you'll be able to write more efficient, flexible loops and avoid common pitfalls. Let's dive in. By the end of today's session, you will be able to apply the break statement to exit loops early and continue to skip individual iterations. Create nested loops for scenarios that require loops inside loops. Evaluate when nested loops are useful and when they can lead to performance issues. Keep these goals in mind as we work through each stage. Let's start with a quick warm-up. For each scenario, decide whether a for, while, or do while loop is the best fit. Scenario 1, print the numbers from 1 to 10. We know exactly how many times. Scenario 2, keep asking the user for a password until they enter the correct one. Number of tries is unknown up front. Scenario 3, show a menu to the user at least once, then keep showing it until they choose to exit. We want one guaranteed display before checking. Discuss these with a partner for 5 minutes, then we'll review together. Sometimes you need to stop a loop immediately before it completes all its planned iterations. For example, the user guessed the correct answer early, so there's no need to keep looping. The break statement serves as an emergency exit from a loop. Think of break like pulling the emergency brake in a car. It stops the loop dead in its tracks and continues with whatever code follows. Here is a simple number guessing game. Notice that as soon as the user's guess matches the secret number, we call break to exit the while loop immediately. If the loop finishes without a correct guess, we notify the user that the game is over. Whereas break leaves the loop entirely, continue skips the rest of the current iteration and jumps straight to the next one. Imagine you're listening to a playlist and skip a song. Continue tells the loop, skip what remains in this iteration. Go on to the next. This is especially useful when you need to filter out invalid data, but keep processing the rest. Suppose we want to print only even numbers from 1 to 10. We could write, here, whenever I is odd, the continue statement skips the console. Right line call and jumps back to increment I. As a result, only even values make it to the output. Next, imagine prompting the user for 5 positive numbers. If they enter 0 or a negative, we don't want to count it, but we do want to let them try again without wasting an iteration. Here, continue skips the count ++ for invalid input. The loop repeats until we have exactly 5 valid entries. Sometimes you need to repeat a set of actions for each item in another set. A loop inside another loop is the natural way to handle this. Think of organizing your closet. For each shelf, outer loop, you might sort each item on that shelf, inner loop. Nested loops are powerful, but can also become computationally expensive if misused, so use them judiciously. Here is an example that prints a simple 3x3 coordinate grid. The outer loop controls which row we're on, and for each row, the inner loop prints 3 column coordinates. Notice how the inner loop completes all its iterations before the outer loop moves to the next row. So, let's see another common use of nested loops, building a multiplication table from 1 to 5. First, we print column headers. Then we print each row with its row label and the products. Each outer iteration fixes the row number. The inner loop calculates and prints row by col for columns 1 to 5. The result is a neatly formatted table. One of the classic exercises with nested loops is drawing patterns. Let's build a simple right triangle of asterisks. Here, the outer loop tracks the current row. The inner loop runs from 1 up to the current row number, printing that many asterisks. The result is a triangle with 1 asterisk on the first line, 2 on the second, and so on, up to 5. Next, let's build a simple centered number pyramid. In this code, the first inner loop prints leading spaces to center the numbers. The second inner loop prints numbers from 1 up to the current row. Together, they form a simple left-aligned number pyramid. Nested loops can be very computationally expensive if you run many iterations. If you don't need every combination of I and j, you may be doing unnecessary work. Always think through whether nested loops are truly required or if there is a more efficient single loop or mathematical approach. To keep your nested loops manageable and efficient, keep nesting shallow, avoid more than 2 or 3 levels deep if possible. Use meaningful names. Variables like row and col are clearer than I and j when loops are nested. Comment complex logic. Explain the purpose of each loop, especially if conditions inside are subtle. Test with small data sets first. Verify the logic on a 3x3 grid before scaling to a 100x100 scenario. Consider alternatives. Sometimes a single loop with index arithmetic or a built-in collection method can do the job faster. By following these guidelines, you'll write cleaner, faster nested loops. Now let's work in pairs to create 3 patterns using nested loops: right triangle, centered triangle, diamond pattern. Spend the next 20 minutes coding these patterns. Focus on using 2 nested loops, one for rows, one for columns or spaces. Test each pattern with small values before moving on. For your lab assignment, you will create an interactive multiplication table generator. The requirements are: prompt the user for the desired size of the table. For example, entering 5 generates a 5x5 table. Use nested loops to display a neatly formatted multiplication table from 1 through the chosen size. Advanced challenge. 1. Allow the user to highlight a specific row or column, for example, by enclosing it in brackets. Advanced challenge 2. Apply basic color coding. Use one color for even numbers and another for odd numbers. Advanced challenge 3. Offer a quiz mode where the program randomly asks the user what e.g. 7x8 equals. Advanced challenge 4. Save the generated table to a text file for later review. Feel free to implement as many advanced challenges as you want to demonstrate mastery of loops and console control. Let's review our key takeaways from today. The break statement exits a loop immediately. The continue statement skips the rest of the current iteration and continues with the next one. Nested loops allow you to perform actions for each element of an inner set within each element of an outer set. Deeply nested loops can be expensive. Always consider performance. Next week we will learn about functions and methods in C# so you can break down your code into reusable modular blocks and keep your programs organized. Thank you for your attention. That brings us to the end of Session 2 on Advanced Loop Techniques. In our next session, we'll dive into creating functions and methods to make your code even more reusable and maintainable. Great work today, and I'll see you next time.